Okay, so one of the things we need to go over is this concept called differentiability. Yep, you heard that right. It's a mouthful. Differentiability. So what does that mean? Well, that's the ability to find the derivative, the ability to differentiate the function, okay? All of these words, they all mean the same thing. Find f prime of x, okay? So f of x, a function, is differentiable at x equals c if f prime of x exists at x equals c, meaning f prime of c exists, okay? So if you can find the derivative and plug this particular c value in and get a result, that means you're differentiable at that point, okay? So how is something not differentiable? Okay, so a function is not differentiable at x equals c if we've got basically three cases to worry about here. Case number one, f of x, the original function, is not continuous at x equals c. Okay, so that's the first thing. If the original function is not continuous, the derivative also has the same domain restriction or the same break in the graph, okay? So if the function is not continuous, then you definitely can't find the derivative there, okay? Second, f of x has different slopes. Remember, slopes are rates of change, okay? So I'm going to write that rate of change on the left and the right. Of x equals c. Okay? Which means graphically we're looking at what we refer to as a sharp turn or a cusp. A cusp. Okay? And we'll see graphically what that means. Okay? But think for a second. What type of function has a sharp turn in it? We'll come back to that. All right. And then the third case for us to worry about. F of x has a vertical tangent line at x equals c. And that's a problem because we know vertical lines, well, they have an undefined slope. And because the slope comes from the derivative, if the slope is undefined, that means the derivative is also undefined, which means there's no derivative there. Okay, so let's talk graphically about what these conditions look like, okay? So let's talk about some graphs. So here are some graphs of functions that are not differentiable at x equals c. So this goes with case number one. Well, here's x equals c. And let's say we have a piecewise defined function with a hole here and then a curve there. Okay, so that's a place where I cannot find the derivative at x equals c because the function's discontinuous. Okay, the second type, we said we would come back to it, a sharp turn. Now, what kind of function has a sharp turn? You guessed it. The one we learn about first is our friend, the absolute value graph. Okay, at the vertex, we have a sharp turn. On the left side, we have the slope here is perhaps -1. On the other side, we could have a slope of +1. We have an abrupt change in the slope of the lines, which means I have a different slope from the left than I do from the right. Okay. Another example of that, let's add on one more picture. Sorry. Thought of one other common type that we see a lot in AP Calculus that you may or may not be familiar with already. Here's x equals c, okay? This is going to be y equals x minus c to the 2/3 power. So it's the cube root of something squared, and it's going to look a little bit like this. I refer to it as the seagull graph because, you know, when I was a kid drawing birds, I always drew them like this. These are all my birds flying in the sky. I called them seagulls. So this I refer to as the seagull graph. All right, but there's a sharp turn right here at x equals c. All right, so that's the issue. All right, let's get rid of these extra birds. All right, and then what about case number 3? Well, case number 3, an undefined. So here's an example of what that could look like. A cube root function. At this point right here, the function is continuous, the function is defined, meets all the things for continuity, but if I were to try to draw a tangent line there, it would actually end up being perfectly vertical. Okay, that's what my tangent line would look like there. And this function, this would be y equals the cube root of x minus c. I don't know why I put parentheses there. You don't actually need parentheses there, but okay. So that's visually what these are going to look like.